Hello everyone and welcome back to Vintage Speedworks. My name is Marco. Today we're working on something that I've had on my mind for a long time, and that is to see if we can build a digital carb synchronization tool. Now I know what you're thinking, there's plenty of those out there for sale, but they're super expensive, and I wanted to see if we can make a video where we try to make one for cheap, like super cheap. So follow along as I cover all the components that we're gonna need and how we're going about building that carb synchronization tool. Now remember, this is a digital carb synchronization tool, so that means we're going to involve a little bit of electronics. So follow along and let's get started on this build. Now our first component that we're going to need for this project is a map sensor. Now a map sensor is something you can get online like I did with this one. I bought this one online for only $8. Now you can get another type or you can get others, but this one specifically is for a motorcycle since it belongs to a Harley Dyna. Now I'll put the part in the description below, but I just want to kind of give you an example of how it works. Now this sensor has a little port here, and that is where we're going to hook up our vacuum tubes to. Now this port here, all it does is it allows the sensor to sense how much vacuum the bike is pulling. And it does that by having these 3 pins here. Now there's a ground pin, there's a 5-volt reference pin or a 5-volt supply, and then there's a reference pin in the middle, which is what voltage is coming out of the sensor. So a lower voltage means maybe not so much pull from here, vacuum pull. A higher voltage might mean more vacuum pull. So that's how we're gonna gauge where we're at with each cylinder, or at least that's the idea. Now I know I can plug this into something like an Arduino Uno, where I can kind of maybe put those values and kind of pair them up with the certain amount of vacuum that we're producing, which is what I wanted to do initially with this project. But for the sake of keeping this simple, we're gonna start off simple. We're gonna keep it just very cheap, and then we'll try to get to a place where maybe we can use something like this 5x7 LED dot matrix, which might allow us to see the levels. But anyways, I really love electronics, so I think we can make it really cool in the future. So I know this will work. However, we're gonna try to build the budget-friendly version of this. So this is a sensor. Another thing that you're going to need is these vacuum tubes here. Now I purchased these online. These were only, I believe, $12. So between this and this, we only spent 20 bucks. So these vacuum tubes for a 4-cylinder motorcycle, you're going to need 4. For this budget build, you might get away with just having 1, but I'll explain how that's gonna work here in the future. But for now, $12, you can't go wrong. These are M5 threaded fittings with a little gasket so that you can put them on your intake manifold. So those are the 2 things that you're gonna need to start your project with. Now, like I mentioned, our sensor needs 5 volts to go into it. So how are we gonna put those 5 volts? Now, the easiest way to do that is to use one of these. Now, this is one of those auxiliary lighter USB chargers for your car. You plug it into your 12-volt auxiliary, and then you plug in your USB to it and you charge your phone. Now, you gotta be careful with this because you wanna find one that is 5 volts and 1 amp of output. That's it. You don't want 2 amps or a fast charger or anything like that. You wanna use one of these inexpensive ones that only go up to 1 amp. This is 5 volts that it pushes out. And the input, if you look here closely, the input is 12 volts to 24 volts. So how are we gonna power this? How are we gonna put the power into this in order for the power to come out to go to our sensor? Now this USB cable, I just cut it, I just spliced it. There's a positive and a negative in there. This will allow us to connect to our sensor, but to connect power to this one, since we don't wanna plug it into our car and have it charging all the time, we wanna have it on this scrap piece of wood that we have here where we're gonna put all of our components. What I'm gonna do is I'm going to use 9-volt batteries. Now, as you can see, I got these inexpensive at the Dollar Tree. It might not last forever. For the sake of this project though, that might work. You can also use other types of batteries, but for this project, I'm gonna use these. And finally, we're going to need a few feet of tube here. This is 3/16 tube. You can use some of this to connect to the sensor, and then we'll have all of our components. So a little bit of wire that we're gonna need, a little stuff that we have in our garage, but that's pretty much it. So let's get working on our project and let's start to put all of our components together on our test board. Okay, so we have our prototype here. I went ahead and put it together. So I put my sensor here. I put 3 clips that came out of a stereo connector, believe it or not. So I depinned these and I used those to install here. Now, you could order a pigtail that has these connectors coming out of it. Of course, that adds to the cost. So I was resourceful. I used this old connector and I depinned it and I used it to put in there. Now, as you can see, we have 3 wires going to the sensor. The white one is going to our positive, which is coming out of our power source, which is this little auxiliary 12-volt USB adapter here. And then the bottom one is our green wire. That one is actually going to our negative connector, which is this one. And it's also attached to the negative connector going to our power source here. And then we have our purple wire, and that purple wire is attached to our positive lead, a positive lead that goes over to our voltmeter here. Now we also attach the negative side of the voltmeter because we want to gauge what voltage is coming out of this purple wire. So that way, since this purple wire is the reference cable, we'll be able to figure out or get a reading from that. Now, in order to connect our USB auxiliary, what I did is I used 2 9-volt batteries. I connected them in series, so that will give me 19 volts. So from there, I'm sorry, 18 volts. So from there, what I did is I connected the positive cable to this little clip here, or to the end of this connector, and then the negative is going to go on the negative side. And as you can see, that's gonna power up our USB connector. That's gonna give power to our sensor. And then we're gonna power up our voltmeter, and you can see we're getting a voltage from that. Now, I don't have anything soldered. I don't have anything connected yet, but as you can see, if we were to disconnect this positive cable from here, from our reference coming from our sensor, then our voltage goes to 0. So that tells us that we are getting some sort of voltage coming from our sensor at rest, which is not, right now it's not actually, there's no vacuum going to this tube here. Now this tube that I connected here, this is the tube that's going to go to our motorcycle. These are the vacuum ports on the motorcycle, so this should give us some vacuum so we can figure out how much vacuum is producing. So this is the setup. Obviously, this is not a finished setup. We still need to solder the connections. If it works on the motorcycle, we still need to do a lot more refining. But for now, this will help us figure out if this is actually something that we can use. So I should point out that this method is experimental. We're only doing this to figure out if we can use voltage to be able to kind of sync our carbs and kind of get the same voltage for each carb. Now, I want to point out a couple of things here. This sensor will output a certain voltage based on the amount of vacuum or kilopascals that it's pulling in. Now, there is a chart that will tell you the voltage in reference to the kilopascals, and that is a linear type of reference. So at a certain voltage, it'll tell you how much vacuum you're pulling in, and it'll give you a certain whether it be in mercury or kilopascals or whatever you call those. But for this demonstration, we're only going to focus on kind of seeing if we can get the voltage even. If we can, and we see that maybe this is something that will work just like this, then what I'm planning on doing is putting all of these components into a box that I can have, and I can simply just pull out whenever I need to synchronize my carbs and go from there. All right, so as you can see, now we have our digital carb sync tool installed to our bike. I have a piece of rubber, it's fuel line hose attached to this vacuum port here that we installed. I'm only doing one right now because I want to test to see if this is actually going to work. Now, if it does work, then what we can do is we can take off our seat, our tank, and then we can install all four. And I'll show you how we're going to do that here in a bit. But for now, I want to see if I could get any type of voltage going to our voltmeter. Now, one thing I did forget to mention is you're going to need a voltmeter. Now, most of us have a voltmeter kind of laying around in our garage, but if you don't have one, you can always purchase one. They're about $6. They're very inexpensive, but you are going to need that as part of this project. And the reason for that is because that's how we're going to get our readings from this digital carb sync tool. So let me get the bike started. Let me get this plugged in. I'm going to turn on our device here, supply the 5 volts to our sensor. I'm going to turn on our voltmeter, and then we're going to see if this actually works. All right, so we have our setup here. This is our prototype that we made. As you can see, I have my positive coming over here. I'm going to connect it to my positive right here, and then I'm going to connect my negative to this side here, little pin here. Now that is going to ensure that I have enough voltage to power this little converter here, or it's more of a step down really, because in a automotive scenario, you have 12 volts going to this one, and then from here you have 5 volts going out to your phone charger. This is the same thing that we have here. However, since we're using two 9-volt batteries in series, we should be getting 18 volts coming out of here. Now, I tested it yesterday. It's actually not. We actually have about 14 volts coming out of these inexpensive batteries going to this, which is fine for this test. But yes, after here, this is where we have 5 volts going this way, and that's powering our sensor here. And then we're gonna turn on our voltmeter. And as you can see, we have 0.15, 0.14, and it kind of settles down after a while. So this is feeding 5 volts here, and then the purple wire, which is the middle pin, is giving us our reference back. So it's only giving us 0.14 volts coming back from the sensor. So we're gonna turn on the bike. We're gonna see if we can draw any type of vacuum. Now, the bike is cold. I haven't turned it on yet, so I'm probably gonna have to let it warm up a bit. And then from there we can see. But I wanted to do this before I turn on the bike. That way we can see if there's any fluctuation in vacuum. So let's go ahead and turn on the bike and test it out. Okay. All right, so I didn't see any fluctuation in the voltmeter here, but what I'm thinking that could be the case is if I have my wiring incorrect. Now, what I think I need to do is, instead of having this cable, which is the ground cable, let me turn this off, going to the ground, I think I need to reference this to the positive cable. Let's try that out. Nope. Okay, so we didn't get any movement from here. I think I need to check the wiring again and try this again, because I think I'm doing something wrong on the wiring. This might be the other way around, because I didn't have the schematic for this, so we might be supplying 5 volts to the negative side. So let me try and move this around here a bit. Okay, so what I'm going to do now is I'm going to install our positive, which is this one. I'm gonna install the positive cable here, which is different from when we had it before. The positive cable was going to the reference. And then what I'm going to do is I'm going to install my negative, which is this one, going to my reference here. Okay, so with the purple one in the middle. So that way the voltage should give us the voltage coming out. And then of course the white one, we're going to install it to our negative. Now we swap these around because I'm not too sure we have the positive and negative going to the right place. We're going to try it this way. If not, what I'm going to end up doing is I'm just going to swap these two, which is the green and the white here, which is the bottom and the top. So I think we have a negative source here, but let's try it out. Let's connect it and see what we get. Okay, so we have, now that turned on brighter than it was before. So, I'm wondering if we had an issue here. Interesting. Okay, so let's try it. Let's test it out again. Let's try on the bike. Right now we have 0.34 there at rest. So let's turn it on and see what we get. Hey, nice. So we have a 1.92, 1.87. And if we rev it up, we have 2.30, 2.45. Nice. Okay, so I have my bike here at idle. It's still warm, it's still cold, but I have my idle set at 1,000 RPM more or less, and I'm getting 1.70. 1.90. Nice. Okay, so that worked. All right, nice. So I did see the bike kind of fluctuating, like there was a lot of back and forth, but I think I can fix that with something that I made just in case this happens. So let me bring it out and let me show you all. This right here is a PVC pipe that I hope will serve as a damper for our vacuum pulses going back and forth. Now what I did is just a regular piece of PVC. I added a bunch of, hopefully you can see that, I added a bunch of coffee straws in here, and I super glued them all around so they can stay right here in the middle. And then what I'm gonna do is I'm gonna attach it to a piece of PVC here on both sides. And I have these connections that I made. So I got these from the Home and Garden Center. They're like little nipples here that I cut and made a hole in the middle. And then I put some marine grade 5200, 3M 5200 silicone. For those of you that are into boats and stuff, you know that this stuff is pretty good. So I'm just gonna put it here in the middle. I'm not gonna glue these yet. I just wanted to try this out. This is the first time I'm going to try this out. So what I'm gonna do is I'm gonna attach my hose here. Connect it here. That's kind of loose. Let me see. Oh, I think this one might not be, well, no, yeah, that's good. Okay, so I'm gonna disconnect my source from the bike, and I'm going to connect that on this side and then connect this one back up here. So let's see what happens now. All right, so hopefully we can get this to operate a little smoother with our voltage. So here we go. Nice. Okay. that is a little bit smoother. Okay, so I'm gonna try to take it off while it's running to see if that affects our voltage. How can I do this? Let me just disconnect it here. Well, we got 1.63, 64. We're gonna disconnect it. We're gonna connect it. And now we have a voltage of 2. Okay, so I think that was affecting our vacuum. I think that might have had some leaks in it. But okay, cool, so that works. All right, so I'm gonna call that a win. There are more things that we need to work on, but we are getting voltage from our little project here. So that means that the reading is actually accurate. The wiring is done. We know that that is working properly. The only thing that I don't like, or I didn't like about this, is the fluctuation of the voltage. Now keep in mind, when we added our damper, or this thing that I made, what happened was that voltage went down because this was causing some restriction. Now, what I think we need to do now is we need to make this have a bigger area inside, or like, yeah, so sort of like a chamber. And that way, if we have more area inside, more volume, then what happens is that vacuum will have a way to cushion that, and that way we can get some more consistent readings. So what I plan to do is I plan to use something like a, maybe like a sandwich box, and I'm gonna put an inlet and an outlet, and I'm gonna put more coffee straws inside, but that way there's more surface area there where we can kind of dampen that voltage more and get a reading. Now, if you notice, when I applied this one, we got a voltage drop, so the readings were different. However, they were a little bit more consistent than when we just connected it directly to the motorcycle. So what I want to do now is I want to do that, create the new vacuum chamber, I guess you can call it. And then from there, what I'm going to do also is I'm going to put everything in this nice little box right here. This box right here, I purchased this at Harbor Freight for about 12 bucks, but this is gonna keep all of our components in here looking nice, and I'm going to be able to run my hoses out of here. I'm gonna be able to put my sandwich box or whatever box I need to use in here for the dampening, and then I'm gonna run all 4 lines out of here. Now, I'm gonna run 4 lines coming out of here into one sensor. And how I'm going to do that is by utilizing one of these, I guess you can call these manifolds. These are for like your aquarium airlines. I purchased this online for like $10. And what it does is it has one outlet or inlet, if you want to call it, and then it has little valves here. Now these valves go to 4 lines. So these are the ones that are going to go to our cylinders, and then this one is the one that's going to go to our sensor. So in essence, what we can do is when we're testing out our cylinders, we can open one valve, get the vacuum for that one, close it quickly, open up the other one, get the vacuum for that one, and then start comparing the readings of all the cylinders. So what I'm gonna do now is I'm gonna put everything together. I'm gonna utilize this valve, that box, our new vacuum chamber to dampen the vacuum coming out of the motorcycle. And then after that, we're gonna give it another try, see if it works. But I'm excited about this. I think putting everything in this box and making everything look nice is going to make a whole world of difference. And of course, that dampening action is going to work a lot better. Now, the voltage that we're getting out of that dampening is not going to maybe be the correct voltage that you would maybe want to get if you were using this, for example, like in an application where you need the sensor to read accurately. The dampening might make a difference there. So we're not really looking for the correct voltage. We're just looking for a voltage that we can compare across all cylinders. I hope that makes sense. So let's give it a try and see how that goes. And we'll move on to the next step, which is putting everything in this box. All right, guys, so here we have it. This is our final product. And as you can see, I went ahead and placed everything into this box. A couple of things that I made, a couple of changes that I made. Instead of using fuel line, I went ahead and just used these vinyl type of tubing, which is fine for vacuum. We're not gonna have it on the bike for a long time, and it's just for sensing of the vacuum pressure. So as you can see here, I added my 4-to-1 little manifold here. I connected that to the piece of tubing, and then that goes into this PVC, larger PVC that kind of wraps around the whole box. Now I did this in order to create a little bit of dampening action. I was gonna use a box, but I wasn't able to fit it in here. So I did this, I connected. I had to get some other connections here because the ones that I had earlier were leaking. So I went ahead and got these threaded connections here. So as you can see from the manifold, the pressure then gets sent here, or the vacuum, and then it kind of goes all the way around. It goes here and then up to our map sensor, which I put a small little bracket here to put on there. A couple of things that changed on this build is instead of using the inverter or that little 12-volt lighter that connected to the 9-volt batteries and all of that, I decided to just get one of these small little power banks. This one has a USB connection here that supplies 5 volts. So that's what I'm gonna use instead of all the other kind of batteries and wires and all of that. All I have to do is simply connect it here, connect it to my USB, and that's going to power our sensor, and then that's how we're going to get the reading. So it's a lot easier to do that. Initially, I had said that you couldn't use a fast charger. Actually, I realized that if the sensor doesn't call for more than 1 amp, then even if you can have a charger that supplies 3 amps, it's really okay as long as you have something that it's going to supply the 1 amp that the sensor needs. So in theory, this should be fine. So that's what I'm going to do. Of course, whenever we're done using this, then we have to unplug this and take it with us, recharge it for next time. So this is our setup here. I'm gonna go ahead and take this over to the bike and try it out. As you can see, we have our manifold here, so I'll be able to kind of toggle between these 4 so I can get my reading, and then close them as we go so we can compare our readings here. But yeah, let's go ahead and put it on the bike. Let's give it a try and see how that works. All right, everyone, so as you can see, I have all the vacuum hoses connected to the vacuum ports here on the bike. I have 2 on this side, 2 on the other side. We have them all routed up here, and we have them connected to our device here. Now, all I'm gonna do is I'm just going to plug in my USB power. So as you can see, we have some power there. That'll supply the 5 volts to our system here. Just wiggle that into place. Okay, so we know we have 5 volts going to the sensor. Now we're gonna turn on our voltmeter here. As you can see, it's saying that we have 0.34 initial at rest. So I'm gonna go ahead and turn on the bike and see what kind of readings we get. I believe on these, if I have the valve open like this, that's open, and then these are closed. So I'm gonna just toggle between them as we go. So let me get the bike started. As you can see, we have only 1 cylinder open. Right now it's in choke. So we have the bike running, and we're getting 1.10, 1.11, 13. All right, so now I'm gonna toggle between this one. So let's open up 2 and see what happens. All right, so we open up 2, it goes up, but if we close this one, okay, so now we have 2.6 on this one. Okay, we close that one, or I'm sorry, that's open. Okay, so this is open, so that's 1.15 on this one. Let's close that one and open this one. Okay, so now we have 2.8, 2.9 on this one. So let's close that one. Hold on, one of them is open, I think. Is it this one? Or are they all open? Let me see. That we have a leak because I'm trying to close all of these. And I'm still getting vacuumed. Might have a leak here. Let me check on that. Alright, so I figured it out. So this is the closed position here. So I'm going to take this one and I'm going to open it up so I can see what reading I'm getting. So I'm getting 1.90, 1.91, 1.90. Alright, keep in mind the bike is not warm yet. So I'm going to close that. Notice how the vacuum stays in the same place. There's no escape from this. So that's why it stays in the same spot. And then I open this one, and this one is at 1.60. So you can see that there's a difference there. So we can use that as a reference to try to get to that one. Now let's check the other one. So we close that one. That one was at 168. Now we open this one. Now we're at 225. So that one's a lot higher than this one. So right now, this one was at 190, I believe, so we can reference that one. So let me close this one. Now we're gonna open this one. Yeah, and so we're at like 190 here. So maybe we can use this one as a reference to tune all the other ones. So let's test all the last one. So the last one here, we're gonna open that up and see that one is at 1.20. So that one's a lot lower than all the other ones. So again, the bike is not warm yet, but as you can see, just by toggling between these, we can use them to try to get them closer to the levels of each one. Yeah, this one is really high, so we need to tune that one down. So once we know which one is the base, we can use this one as the 191. 190, then we can start tuning all the other carbs to the 190. So this one we would go up a little bit. I have the tank on this, so I'm not going to tune them today, but as you can see, it's a very simple process. We just open the valve and you can see we have a steady vacuum there. Now again, we need to let this warm up, so yeah, let's do that on the next video. But for now, I just wanted to show you that this simple device that really it's fairly inexpensive. You know, it does the job to be able to tune, kind of get the carbs to the same place. Now you got to make sure that these valves are completely closed, straight like that, so you don't have any pressure. But yeah, so let me turn off the bike. As you can see, the pressure stays there because it has pressure in the pipe here. But if I were to open up this valve, going back to the cylinder, as you can see, it releases the pressure or the vacuum, and now we have 0.37, which is what we have on the rest. So yeah. All right, everyone, I think I'm gonna call that a win. I mean, this thing works awesome, and I think it's gonna be able to allow us to check the voltage as far as how we are in comparison to each cylinder. So I'm gonna keep tweaking with it. I'm gonna keep trying to get all the carbs synced together to see if that makes my bike run a lot better. But for now, I really am happy with the results. This was a project that I had in my mind for a long time to see if we can get it working. and I think we got it working pretty well. So I hope this helps some of y'all out there. I am gonna ask that you please subscribe to my channel. I just started my channel and want to create more content like this to help some of you out there. Because things like this, honestly, it just takes a little bit of time to put it together and a few bucks, and you can get it working just as good as some of the expensive stuff out there. So I appreciate y'all watching. Thank you all so much for subscribing again if you do decide to subscribe, and I'll see you on the next one.